This lesson is converting data from one type to another. The objectives for this lesson are to learn about the convert class, using the C# cast operator, performing implicit number conversions and performing explicit number conversions, and converting numbers to strings. You need to be very careful about doing numeric conversions. So there's a handy numeric conversion chart up on Microsoft's website. You can get to it by this URL here. And what it'll talk about is doing what are called implicit conversions, where you take a smaller data type and you convert it to a larger data type. For example, taking an integer to a decimal, or an integer to a double, or an integer to a float would be an example of something that you can just do implicitly. An explicit conversion means you're trying to take a larger data type and converting it to a smaller data type. And you can't do that without some sort of explicit cast, which means you need to be explicit about what you're doing, because there will be some loss of data and you need to understand how that explicit cast actually works before you do it. And we're going to see that in this lesson. So let's start out and take a look at doing an integer to a decimal, which is one of the implicit conversions. On line 1, we create an integer variable called quantity and assign it a value of 10. Line 2, decimal result. On line 4, we say result equals quantity. So this takes that integer value, converts it to a decimal implicitly, and then it's now a decimal. Result is actually a decimal data type. And when we display it, it's still going to just display 10 because there's no decimal portion on an integer. But this is an example of an implicit conversion. But let's now take a look at decimal to integer. So now there could be some loss of data, so we need to know what we're doing and we need to do an explicit conversion. Let's flip the two values around. So now decimal price equals $5.99. So there's a decimal portion there. And what we want to try to do is put that into this int result. But on line 5, you'll see we're getting that red squiggly underscore there, which means it will not compile. It's giving us an error. If we were to check the error list, view error list, we can see it says you cannot implicitly convert type decimal to int. An explicit conversion exists. Are you missing a cast? Okay, that makes sense. So that means we need to add different code here. And there are two ways that we can do an explicit cast. On line 5, we can use the convert class and call its toInt32 method. And we pass in the decimal value to that, and it will then return that as an integer. Now, what does that mean? It means what it's going to do is it's going to go in there and round to the nearest whole number, because that's the way the int32 method works. The other way is result equals int operator. So this is a casting int operator. Within the parentheses, you put a data type and then put that right up to the variable name, in this case, price. What this one will do, however, is it will truncate the decimal portion. Let's take a look. If I run this, the first one, the convert.toInt32, rounds up to 6 because of its $5.99, whereas when we do the cast operator on the int data type, it actually just truncates off any decimal portion. This is why it's so important for you to understand the differences between implicit and explicit and know what each of these different ways will do when it's converting the data. Let's take a look at our next example where we're going from a decimal to a float. So again, we're still going from larger to smaller. Float doesn't have as many bytes that it can contain as decimal. So again, we need to use an explicit conversion. I've put an incredibly large decimal value into the value variable here. And then I have a float result. And then on line 4, we do result equals, and then we're using the cast operator with the float data type on value. And there is no convert.toFloat, by the way. That doesn't exist. So we do a cast. And what's going to be interesting here is that even the whole number portion, 51234235, that's at kind of the limit of a float. So when it does this, look at what it does. it actually rounds it and doesn't give me any decimal places at all because there's not enough room in a float to express that whole decimal value. So again, very important to understand when you're going from one data type to another. Now, I'm going to be very honest with you. I generally don't do this. If I'm going to use a decimal, I'm using a decimal. There's no reason for me to convert down to a smaller data type typically. Okay. In fact, I can count on one hand the amount of times I've ever had to do it. So it's not something you're going to do very often, but I wanted you to at least be aware of these differences. What if we get in a string value from somewhere and we want to convert that to a number? Now, this is something you'll probably do quite a bit, and there are a lot of different explicit conversions we can use for this. So let's take a look. Now, as I said, string to a number always has to be an explicit conversion. You can't use the cast operator here. As you can see, we get that same sort of error message. So we use the convert class, and I'm going to an integer. So it's just going to take that string and attempt to convert it to an integer. So I'm going to go ahead and run this, and it converts to an integer just fine. But what would happen if I put some sort of character in there? There we go. We get an error that says the input string was not in a correct format. It will get a runtime error in this case. So you, again, need to be very careful about doing this, making sure that you have the right type of value in that string. Now, if we are going to a decimal, there is a convert.toDecimal method that we can use. So if this is in a valid format, it can do the conversion. It's never a good idea to use that convert to int32 on data that you don't know could be wrong or right. In that case, always use the data type's TryParse method. So in this case, I'm going to convert to an integer. So I'm going to do if int.TryParse on that string, and then I'm going to use the out parameter on result so that if it can convert it, the value will be in that result. Otherwise, this will return a false, in which case I'm simply going to display on the console not a valid integer. If we run this, we get the 10 as we'd expect. If I then change this and add some weird character in there that will not parse to an integer, now I don't get a runtime error. I'm handling the error, and I'm going to do something with that, like put a message up to the user and say, hey, you need to re-enter this. You didn't enter it as an integer value, or something to that effect. So definitely take advantage of the TryParse method on each of the data types. Let's now take a look at converting a string to a DateTime. Once again, an explicit conversion. In fact, you'll find most often you're going to be doing explicit conversions as opposed to implicit conversions. So once again, we define a string variable. I've called it DT, and I assigned it to a string that looks like a date. I then have a DateTime variable called result, and on line 4, result equals convert to DateTime, passing in that string. And as long as it can be converted, everything works just fine. However, if we put something in here that's an invalid character, now we're going to get that same type of runtime error, and we don't want to get runtime errors. We really want to avoid those. So it's telling us that, hey, there's an unknown word starting at index 3, which if you count it up, 0, 1, 2, 3. It's telling us pretty much exactly where that problem lies. So this is a case, once again, where we'd want to use the data type's TryParse method. So we're going to try to parse that string variable called DT, and if it does it successfully, the results will put into this DateTime variable called result, and then we can display that on the console. So if we run this, it will display that value. If I were to change this again, we're now not going to get a runtime error because we're handling it. We're saying I've tried this out, and that is not a valid DateTime. So our last example here is going to be converting a number to a string. In this case, we have a decimal, price equals $5.99. We have a string result. Well, this one's probably the easiest one to do. We're always going to use that toString method. We use the toString a lot, as you've seen throughout this course. So on line 4, we simply do result equals price.toString. On line 7, result equals price.toString, and then we're going to pass in a lowercase c, which is, you remember, gives us the currency representation of that. And then on line 10, the other thing we can do is convert .toString. So we use the convert class and use the toString method on that decimal variable price, and it returns that result. If we then run this, we can see the values, the outputs from converting the decimal to a string. In this lesson, we saw that numbers can be implicitly converted from a smaller to a larger type, but they must explicitly be converted from larger types to smaller. And as I also mentioned, you really aren't going to be doing that many implicit ones, and you're generally not going to be changing data types from one type to another that often when you're dealing with numerics. However, taking data types and putting them into a string, that's something you will probably do quite a bit, and for that you're typically going to use the toString method or maybe the convert class's toString method. Coming up in the next lesson, handling exceptions in your code, throwing and creating your own custom exceptions.